Hi, and welcome back. Now that we have a good understanding of what a theory is and what concepts are, let's think about how to use our theories and concepts in a way that we can actually test them. So to do that, we're going to need to convert our variables to concepts. So here's an overview of what we're going to talk about. We're going to talk about the idea of operationalization and indicators, converting a proposition that states a relationship between two concepts into something that we can actually test. We're going to look at properties of an operational definition. We're going to examine what variables and hypotheses are. And then we're going to look at what independent and dependent variables do within a hypothesis. All right. So to start off with, let's ask ourselves, what is operationalization? Operationalization is the process of selecting observable phenomena to represent abstract concepts. So when we operationalize a concept, we're specifying the operations that have to be performed in order to establish which category of the concept is present. For example, classificatory concepts, or to the extent to which the concept is present, comparative and quantitative concepts. The end product of this process is the specification of a set of indicators. Indicators are observable properties that indicate which category of the concept is present or the extent to which that concept is present. In order to test our theory, we examine whether our indicators are related in the way that our theory would predict. The predicted relationship is stated in the form of a hypothesis. A hypothesis is logically implied by one of the propositions that make up our theory. Because it's logically implied by the proposition, evidence about the validity of the hypothesis can be taken as evidence about the validity of the proposition. Just as it is possible to represent one concept by several different variables, so it will also be possible, and in fact desirable, to represent one variable possibly by even several different indicators. So the operational definition specifies the indicators by setting out the procedures that'll have to be followed in order to represent our concept empirically. And a properly framed operational definition is going to add the precision to our concepts and makes our propositions testable. This, of course, ensures that our knowledge claims are transmissible and makes replication by other researchers possible. So, what is a variable? When you think of a variable, concepts themselves are abstractions and they represent empirical phenomena. In order for us to move from this conceptual theoretical level to the empirical observational level, we have to find which variables correspond to our abstract concepts. A variable is a concept's empirical counterpart. So when we take a concept and we think about how we can actually observe that concept, the way that we come up with that method to observe the concept will produce a variable. Now, a variable is any property that varies or takes on different values. Anything that takes on different values can potentially be a variable. And our variables are empirically observable properties that take on these different values. Some variables have many possible values. For example, income might have, someone might make $1,000, someone might make $50,000, and anywhere in between. And some can only take on a couple of different values. For example, gender, where you have males and females. The statement that specifies the relationship between our variables is what's called a hypothesis, right? And in order to test our theories, we convert the propositions that links the concepts within our theories into what's called a hypothesis. A hypothesis is a conjectural statement that specifies the directional relationship between two variables. Two and only two variables. A hypothesis is logically implied by the proposition. It's more specific than the proposition and has much clearer implications for testing because it's a relationship between two variables, and variables are things that we can directly observe. The relationship we expect to observe between these variables should be self-evident from the hypothesis. The hypothesis should essentially be a statement of the test we're going to perform to critically evaluate the validity of our theory. All right, so here's an example here. Think of a concept as economic dependency. And as we think about what we mean by economic dependency, we think about how we could possibly measure economic dependency. And you might come up with something like the reliance on a limited number of trading partners, a limited range of trade exports, the extent to which foreign ownership is present within a given country, etc. Or socioeconomic status. We might look at an individual's income, occupation, and education. Together might be the variables we would want to observe to measure the concept of socioeconomic status. Or think of something like political sophistication. I think everyone can understand when they say that someone is more politically sophisticated than someone else. But as you think about how to measure it, you might say, well, someone's ability to use left-right terminology, or how much knowledge they have about politicians and processes and politics in general. These are all different things that we could observe, for example, through an interview. The different variables used in a hypothesis, think of them as cause and effect, or antecedent and consequent. But normally they're referred to as independent and dependent variables. So these variables are classified, of course, according to the role that they play in our hypothesis. The dependent variable is what you want to explain. For example, someone interested in explaining voter turnout is using voter turnout, or the percentage of people who turn out at a given election, as the dependent variable. The dependent variable is what we want to explain. The independent variable is what we presume explains the variation in the dependent variable. So as values change on the independent variable, we expect to observe values to change on the dependent variable. For example, the older someone gets, the more likely they are to vote. So we're varying age, the independent variable, with the probability that someone votes, the dependent variable. The independent variable is independent because its values are independent of any other variable indicated in our hypotheses. Another way to think of this distinction is in terms of, as I suggested before, antecedent, the independent variable, it comes before, and consequent, the dependent variable, it comes after. We make our predictions from the independent variable always to the dependent variable. So to recap, I want you to take a look here at this slide, because in the top left we see the concept, and then to the right of that concept we see another concept. That's two concepts being linked by a proposition. And an example of two concepts being linked by a proposition is the more disadvantaged a person is, the more cynical he or she will be about politics. Now you can imagine that statement and you say, I imagine that theoretical perspective I could probably go out and find evidence in support of, or find evidence that makes a claim about whether that's a valid theoretical perspective or not. When you do so, you want to think of what you mean by disadvantaged and what you mean by cynical, and how you're going to observe and measure these two different concepts. So let's say that we said disadvantage was best measured by the level of a person's income. The concept, disadvantage, is being measured by the variable income. And similarly, cynicism, the concept, is being measured by the variable, how likely it is that someone is to think that politicians keep their promises. So at the conceptual level, we have a proposition that links two concepts. And as we move down to an observational level, we have a hypothesis that links two variables. Thus, we'd say to hypothesis, the lower a person's income, the less likely he or she is to think that politicians keep their promises. So to recap, we've looked at operationalization and indicators. We've thought about converting a proposition that links two concepts into a testable form. We've thought about the key properties of operational definitions, what are variables and what are hypotheses, and the role that independent and dependent variables play within our hypotheses. Great job so far. When we move forward, we're going to actually look at some of the common problems with stating a good hypothesis. That's it for now. Great job, Government 300 students. Move immediately to the next video on writing a good hypothesis.